Well, it is the Monday after Super Bowl 2014 where the Seattle Seahawks absolutely devastated the Denver Broncos 43-8. But you know what? I don't really care because I'm not a football guy. But if you want to get me to act like some of these screaming, raving mad fans tearing their shirts off and painting their faces in sub-degree weather, parade me in front of a bunch of Cisco carrier grade routers. I'll be like, oh, is that a CRS-3? Oh, come on, turn it on. Woo! There goes the shirt, paint's flying everywhere. Boot, router, boot, woo! Because it's all where your passions lie, right? So that's what we're going to talk about in this nugget is the Cisco service router routers. First off, going back to the big picture, what does the service router network look like? Then, what equipment fits in each one of those components? Here are the do I know this already questions. So pause the video, read through them. If you know those answers, move on to the next nugget in this series. I'm really digging this artistic interpretation of service router graphic because it does a good job of taking these massively complex and far-reaching service router networks and boiling them down into two basic components: aggregation nodes and core devices, right? So for this graphic, and now moving forward, we're going to refer to these as provider edge equipment and provider, we'll just call them core devices, essentially what runs the core of the service router. The provider edge equipment is responsible for doing exactly what this word says right here, aggregating the hundreds or thousands or hundreds of thousands of different subscribers that you might have as a carrier into fiber optic strands that feed into the core. Maybe you're a cellular provider, which no longer is just cell service of people talking on phones, right? We now have tablets and smart devices, iPhones, Androids, which could be doing all kinds of things that are coming to these towers, being aggregated into your Sonnet ring, which feeds into the central facilities of your service router, or one of the centers of facilities of your service router, where they encounter the core devices. And when you get into the core devices, you're really thinking about, well, I'll say three major things that's just coming to my head right now. Number one is throughput. How much capacity can those devices handle as you add more and more subscribers that put more and more demands on your network? Second would be redundancy. How do they handle a failover? I mean, if you lose a full chassis of equipment, do hundreds or thousands or hundreds of thousands of subscribers notice? Hopefully not. Hopefully you can fail over and have that redundancy without batting an eye. And then third one would be how you're routing these. I mean, you've got these cellular connections coming in, which maybe are going to other ISPs. I mean, it's funny when you really take a step back at the worldwide network we call the internet, you really do start getting the feel and going, wow, this really is just a network of networks. As we're looking at it from a service router perspective, I mean, maybe these guys on their cell phones are surfing. Of course, Google comes to mind, but let's just say, surfing CBT nuggets, right? So as a service provider, do you host CBT nuggets? Is CBT nuggets in their facilities just one of the aggregation, connected to one of the aggregation devices, to where that cell phone surfing CBT nuggets just passes through your core and then routes right out to another POP, another facility that you have, and now you're seeing CBT nuggets webpage? Or does it link up to another carrier, another ISP, which links over to, for example, Amazon Web Services, which is where CBT Nuggets hosts a lot of their content from? So it really is just a network of networks. Or maybe you have a business here, which is going through, through that aggregation device, through the core to reach another facility of that business. That would be known as a VPN. Now, I know you're thinking, well, VPN, are you talking like, I've got my laptop with a VPN client installed so I can get to the office? No. VPN has been kind of coined with that, but it really doesn't mean that at all. That would be an encrypted connection over a public network. VPN, virtual private network, truly is a generic term. It's essentially, let's just say this is Nabisco, right? Nabisco, Texas. Office. I can't even write while I'm talking. Nabisco, Texas, linking to Nabisco, Michigan office, right? And so they are essentially, obviously Nabisco doesn't own the service router. They are contracting with the service router, assuming that the service router is, well, I would say more than assuming, there's going to be documents that they sign, confidentiality releases and all that, that says the service router will not be looking at Nabisco's proprietary information going through that. That's what we would call a VPN. It's virtually private because the service router, essentially us, has guaranteed Nabisco we're not going to be watching their stuff, but it's not truly private, meaning Nabisco didn't get out their shovels and dig a trench from Texas to Michigan and run their own cable so that they can say it's not just virtually private, it's truly my own private cable that I'm running. So all of these decisions are going through that service provider world, and essentially what I want to do in this nugget is identify the devices that go in each place. Well, let's start off with the service provider edge equipment, beginning with the ASR 1000 series. Now, let me first off tell you that I cringe at slides like this because I've been teaching long enough to know that by the time the words leave my mouth, Cisco will have released a new series or increased the capacity or added a new module or blah, 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 and I'd be, oh, it's outdated and that kind of thing. Yes, 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 I know, but I had to take the risk in this case because I realized this is the CCNA service provider series. A lot of times people are coming in without ever seeing service provider equipment before and knowing what it looks like and feels like and smells like. At least I'll be able to get one of those, right? What it looks like. And I'm going to take the risk that you'll be able to take the concepts that I'm giving you with these models and bridge them over to whatever Cisco has. And I know you'll be able to. So starting off with the ASR 1001, smallest one that they created, has a 5 gigabit per second throughput, total throughput on it, and one shared port adapter, SPA. Now, that's just a fancy Cisco word for a module, right? Looking at this graphic right here of it, this is the module. I know it's kind of small, right? But you can see the screws sitting there on the side. So whoever had this image created had installed, it looks like a module of SFP, small form factor pluggable fiber optic interfaces. But if they didn't want that, they could take it out and put in some serial interfaces, maybe to support some frame relay customers, or whatever. They can change that to whatever interfaces they would like to, and it makes it a little flexible, along with having built-in gigabit Ethernet interfaces on there. Now, I also want to mention that every single one of them, I have it on all of these, have redundant power supplies. If there's going to be something that goes out, most often it's the power supply, and unfortunately takes down the whole device, right? So any highly available equipment will want to have redundant power supplies. And now, before we go any further and we talk about the other flavors here, can I hit these purple notes? They're big ones. All ASR 1000 devices run iOS XE, right? So I'm going to take you on a throwback to the very first CCNA Service Provider series, NGN 1, where we talked about the different iOS flavors. There's iOS, which is what made Cisco famous. It runs on all their mainstream customer equipment. To this day is the de facto standard on command line management of your devices, right? Well, along the way, they created iOS XE. And then that finally fed into, got to have a third color, right? iOS XR. So iOS XE runs only on the ASR 1000 series, which is what I'm talking about right now, and I think the 4500 series switch, but really is just kind of a step. It's a stepping stone towards iOS XR. The biggest thing that it did when it moved from iOS to iOS XE is, first off, change the core kernel. Essentially, iOS was its own thing. iOS XE ran on the Linux kernel and separated a lot of the functions of the iOS. The big drawback of the iOS is its monolithic design, meaning it's an all-in-one software. In the, I'm saying the old days, but the current days, if somebody's running the iOS and they need a new feature, they have to replace the whole software. Right? So iOS XE and, of course, iOS XR modified that by allowing individual feature upgrades and also separating the processes so where maybe BGP or a switching component or an access list or whatever, some feature of the iOS could die and not take down the entire platform, right? Because it's separated in memory, making this device more available than the traditional iOS devices. So all of these that you're seeing right here run the iOS XE, and then the mainstream carrier devices use iOS XR, which is a complete rebuild of the iOS from the ground up, reconstructed. But there will be a learning curve. Did I mention this? iOS XE looks like, feels like, tastes like iOS. So you will not have to learn a whole new command set or working with it like we talked about in NGN 1. We looked at iOS XR, what the differences are from a command line perspective. iOS XE, we don't really have to do that because all the commands are the same. It feels like the normal iOS. These things also run dual iOS processes. A lot of times you'll hear it referred to as dual iOS. That doesn't mean that it's running different versions of iOS, or one's iOS and other's iOS XE, all that kind of stuff. What it does mean is that it runs an active and standby flavor of the iOS. Now on these guys, they have a single processor, single route processor. So it will run dual iOS, meaning multiple versions of the iOS on one processor, one active and one sitting there in standby. Now, the beauty is if one iOS freezes, essentially the software crashes, not that Cisco would ever have a bug, but if they did and the software crashed, it would fail over to the completely redundant version of software running in memory. Still supported. Now, again, on these lower end devices, lower end, they're carrier grade, so they're high-end devices, but lower end in the ASR series, they'll be running off of one processor. So if you lose the processor, then you still lose the unit, but at the same time, I mean, that goes for just about anything with a single processor. It does add a level of redundancy. Okay. So ASR 1002, you can see just increases the capacity, and I can fly through the rest of these. 3 shared port adapters, so you can see 3 modules sitting there as we move up. 1002-X increases the capacity significantly, but again, still has those 3 form factors, but 3 shared port adapters. Talk faster, Jeremy. But you can also see add some more built-in interfaces in the chassis itself. Now we get into the higher end ASR 1000 routers. Like you can see the 1004, we've now increased to 40 gigabits per second capacity, 8 shared port adapters, 8 modules that we can expand with, and redundant power supplies. But look at what happens right here. Once we move into the ASR 1006 and 1013, we not only go off the charts in terms of capacity, but also add redundant service modules, or essentially supervisor modules. I said service supervisor, you can use them interchangeably. These guys right here, essentially the brains of the device. You remember when I was talking about that dual iOS mode previously, I said, well, if you have that route processor and it fails, then you lose both of the active and standby. But with this guy, so 1006 and 1013, you actually have redundant supervisor modules or redundant route processor, and what it will do for dual iOS mode in this case is actually run the active standby iOS on different supervisor modules. So you can lose an entire route processor, an entire module, and still maintain your device running on a secondary, which will now flip over to the standby iOS. So, when you move into the boxes that are this big, redundancy becomes absolutely key. You can also see the redundant route processor support ISSU, meaning once you have these redundant supervisor engines, you can support an in-service upgrade. ISSU, I'm missing in-service software. That's what it is. In-service software upgrade, to where you can actually upgrade the iOS while in production. And I would tell you, I would still, no matter how many times you do that, still feel nervous about doing it on a production router, but it works. Essentially, you can upgrade the iOS on one supervisor while the other engine is running and then flip back and forth between the two. So you can actually have a full upgrade of your software without anybody noticing on these platforms. So that's the benefit as we move into these gigantic platforms. Can I also mention this? We're talking about edge equipment, but keep in mind this is just where does Cisco position these devices? Meaning, if you're a smaller service router, if you're a small service router, you could run your core service provider network off a Cisco 2900 series router. Put a couple of these routers in the middle at a carrier, linked to an edge device, which maybe is an 1800 series router you bought off of eBay. I didn't say eBay because that would be not legal to use in production, but say you got it legally off of another website and you use that to connect to your customers, your few customers that you have as this small carrier. So you can use, you might look at this guy and go, good grief, that's an edge device. Sure, for some. For others, you might use that as your core device. It can have the same functionality to run a core service provider network. I'm just talking about product positioning. I make that statement as we transition from the ASR 1000 into the ASR 9000. These are still officially, if you go to Cisco's website and say, what is an ASR 9000 series, they would list it as service provider edge equipment. But good grief, there is no shame and using. I mean, look at that thing, 9922. That's where the football player in me comes out. That thing is a full rack, beastly piece of gear with huge amount of throughput and capacity. By the way, I didn't even want to visually fill your brain with the stats and figures of modules and throughput because it changes so often. So if you want, head to the Cisco website. You can actually fill in some of those gaps. But really, as you move from the 1000 to the 9000 series, you make two jumps. One, you move from the XE to the XR flavor of the iOS, as we were just talking about. But also, I mean, just looking at these devices, you can tell they have increased port density that they have, so you can connect more devices to them, and overall an increased throughput so that they can handle more customers. That was an intentional moment of silence as I come to the Service Router Core equipment because I figured this would simply take your breath away to see these devices. These are the core routers that run the lifeblood of service routers. Two series I want to talk about. The XR12000, which is the older one. You can tell it runs iOS or iOS XR. It's been around for a while. Doesn't have the capacity as the CRS, I'll just say X or 1, 3, and X series have. But let me tell you, there is no shame if you are a service router running the XR12000. There is no shame in seeing these in your devices. Definitely a beefy router with a lot of throughput. Many different models. Again, go to the Cisco's website, pull up the data sheet. Each one of these is considered a module or a slot. Depending on the series that you get, these can either be 10 or 40 gigabits per second of capacity. And that tells you nowadays that we're even running 10 gigabit per second sonnet rings, things like that. We go, oh, okay, so we're maxing out a slot with just one of those. I mean, it kind of tells you where this thing is positioned, and it is slowly being replaced by the CRS-1, the Carrier Routing System. I can still remember this is some time ago. I can't remember the date, but I was at a Cisco Networkers or Cisco Live conference, and they had first rolled out the CRS-1, and I was having people take pictures of me standing next to one. I put my arm around it like it's my friend, and on my cell phone. I can't find those pictures. I wish I could, but nonetheless. CRS-1, CRS-3, CRS-X. This is not a generic flavor. This is the latest edition of the CRS to come out. You can see that these are 4, 8, 16 slot systems or shelves. I mean, they are essentially full rack units. They even have multi-shelf systems where you actually take fiber optic cable and connect these together with 2, 3 fiber strands, and it really combines the capacity of them. And you can see down here I've put the different series. This is CRS-1. If you use the multi-shelf system, meaning you're combining multiple chassis together, you can get a maximum throughput of 92 terabits per second. As you move to CRS-3, which today I see a lot of those, it's 322 terabits per second. These, again, today are just out, so they're still very new. I haven't seen any of these, but if I do, I will touch it. I haven't seen them in production yet, but 300 or 921 terabits per second. Do you feel the theme as we're going between these? Essentially, Cisco, as they release each one of these series, which they really noted with the model change here, is increasing the capacity by 3. With each jump in the series that they go to. And obviously, as they went X, they probably plan on this series lasting for quite some time. And I know you've probably read this and going, seriously? Probably. But, I mean, these things, you're talking the amount of electricity to essentially run a neighborhood to power one of these devices for a month is necessary. I mean, these are extremely high-powered, extremely high-throughput core devices. Obviously, all iOS XR. Well, for those of you that have never seen carrier-grade equipment before, I really hope this puts some visual and logical pictures in your mind as we start talking about each one of these areas of the service router network. First off, looking at the artistic interpretation overview into the individual edge and core devices. I hope this has been informative for you, and I'd like to thank you for viewing.